Okay, we have established that we know how to differentiate some of these functions, guys. Rayhan, we're getting on with the next bit, okay? So I've said we know these three facts here. This is a screenshot of what you get on the formula book, okay? We've just looked at these three. We may have touched on these. We're going to touch on these later. But because we know these three things, what else can we work out if we know how to differentiate those functions? Yeah, fascinating, okay? We now know how to integrate functions that look like this, which is what you will spot on the formula page. The ones that we should be using are this one and this one that we've got here. Why have they not said, why is there nothing that's integrating to arccos? Why have they only got arcsine and arctan? Mm-hmm.
I really don't know what.
If I was going to ask you to integrate this,
Isn't it the same as arcsine?
it's the same as arcsine apart from it's negative. So if I wanted to integrate this, I would get arcsine. If I wanted to integrate this, I could get arccos, or I could get minus arcsine. Yeah? So that's... If I was going to integrate this, it would give me arcsine. If I was going to integrate this, I could get arccos, or it's going to be the same as minus arcsine, because there's just the minus here instead. Correct. Arccos is the same as minus arcsine. Must be. I mean, how could it not be? Yeah, I'm guessing. I mean, I find that hard to imagine, but that's what it seems... I know. That's what it seems to be telling us, though, isn't it? Yeah. So it must be that way. So we're going to try and play around with these two things that we've got here. And then basically what we're doing over the rest of methods in calculus is we're going to be doing all of these things down here. We're going to be looking at all of these things down here as well. And so these complete the picture. They complete the jigsaw puzzle of all of the different kinds of functions that we can integrate, because none of these functions here would be able to integrate using reverse chain, substitution, any of those kind of things. They would all need to use, well, they could be done with substitution, but they would all need to be done in this particular way. They always come up with these kinds of functions. So we're going to kick off with actually quite a challenging thing here. We are going to show that the integral, which is from the formula book here, the integral of 1 over a squared plus x squared with respect to x is 1 over a arctan x over a plus c. And the way that we show this, in fact, the way that we show any of these ones that we have down here, these four that I've got written, the way we show any of these is by using a substitution. Now, the substitutions that we're going to use are all clues in the answer. So the formula book actually tells you which substitution you should be using, okay? The substitution that you will be using for the one that integrates to arcsine, surprise, u is going to be a sine x, okay? For the arctan one, u is going to be a tan x. For the arcosh one, u is going to be a cosh x, and for the arshine one, u is going to be a shine x. They tell you which substitution that you should be using simply because of what kind of function it is actually integrating to. So the formula book is going to give you that hint. I'm going to show you why those substitutions are the ones that work. What's your question, Luke?
I just don't know. I can't see where you got the substitutions from.
Just it shouldn't be obvious really, but just because this function integrates to an arcsine, I'm just saying the clue is it's going to be a sine x, the substitution. And because this one is is to do with tan, it's going to be a tan. And that one's cosh, so it's going to be cosh. That one's shine, so it's going to be shine. That's all I'm saying at this stage. It gives you like the hint of what it's going to be. And I'm going to show you why this substitution will work here, okay? So the appropriate substitution for this bit is going to be that u is equal to a tan x. Don't worry about these bits here or anything. We're just going to say it's a tan x. Why is that going to do anything particularly pleasant on the denominator here? I've written them completely wrong. That's why. It shouldn't be u is equal to a tan x. It should be that... Yeah, I'm really sorry because I've just written that out wrong, but it's going to be the same for all of these things here, okay? It's just going to be the other way around. But you can figure that out, okay? should have read the question a bit more clearly before I dived in. So we're going to say x is this. My apologies.
But when we do information by substitution, we start over u is equal to something. Right?
Yeah, but we're trying to substitute something into this bit that we've got here.
So why does that work?
Why does this work?
Yeah, 'cause
What was the question?
Why does this work? Yeah, so if you substituted this in here, what would change about it?
The x would become a tan u.
Okay, so
So then
if you substitute x in here, what does this become?
1 plus a squared plus
Fan.
that squared.
No, not fan.
Okay, so you get 1 over a squared plus a squared tan squared u.
Or 1 plus tan squared.
So you've got a 1 plus tan squared,
Sec
which is a sec squared, so we're going to get some things that are all going to come out really nicely here.
A
So this is the reason that we use tan u here, because you get the 1 plus tan squared identity coming up. And in this one that we've got down here, we will look at these later, you will get the square root of 1 minus sine squared, which is a nice identity. This one you'll get, down here, you'll get the square root of cosh squared minus 1, which we know cosh squared minus 1 is going to be sine squared. And this one you've got 1 plus sine squared, which we know is cosh squared. So you pick the correct identity, the correct trig substitution that will give you a nice identity. Sorry?
Is it cosh plus sine, shine is 1?
Cosh minus shine is 1. So you get the nice identities will all happen here. Okay, so this is the substitution that we're going to use. We're going to say that x is equal to a tan u. Now,
So the one that we use is whichever one it looks like.
exactly. Yep. And the reason that that is because it's always going to create some kind of identity in the denominator. Sorry that I wrote them with the x and u the wrong way around at the beginning. That was probably a bit confusing. So for a substitution, we actually need to do the substitution. So we've got 1 over a squared plus x squared dx. So we're going to do the substitution there, but we also need to find out what dx is equal to. So what do I need to do here?
differentiate.
So I get dx du is,
A theta.
So
what does this differentiate to?
a sec squared u.
Sec u tan u. Or that. Or
Just that.
Sec is sec.
Sec
or
is
that,
sec.
yeah.
Tan goes to sec squared, okay? So when I now do the rearranging here, dx is a sec squared u du, right?
Yeah.
So 1 over a squared plus x squared dx is 1 over a squared plus a squared tan squared u multiplied by a sec squared u du.
But then the sec squares will cancel out as well.
So the sec squareds are going to cancel out, but I'm going to take that a little bit slower. So I've got 1 over a squared, 1 plus tan squared u, multiplied by a sec squared u du, which is 1 over a squared sec squared u. Yeah, why not put that all together? And then on the top I've got a sec squared u du.
So the a will cancel out, so the sec
So this will all simplify to 1 over a du. What does 1 over a integrate to?
Minus 1 over a to the
No,
It's not
because
with
one
respect to a, it's with respect to
No,
u.
So you just 0. No,
No,
it's just
What is
1
A?
over a u.
It's just 1 over a
Tan
u
Or u over a.
plus c.
Because it's integrating. So you,
Oh.
if you've
Oh,
just
oh,
got a
yeah,
number and you're
yeah.
integrating it,
Oh,
you just
cool.
times by the.
Yeah.
Oh,
Okay? Now I'm going to just quickly grab this thing and I'm going to just shift it across because it's got in my way. So it's 1 over a. Well, what's u?
We said it is. X
Whoa,
over
that
A-
went weird. So it's
tan
x over a
is equal to tan u.
tan.
is tan u.
And then
So
Tan.
arc tan x over a is u. So you get 1 over a arc tan x over a
plus c.
plus c.
Oh, and that's
Look
from
at
the
that.
yeah.
Nice.
Time to write this all down.
So I'm going to give you some time to write this down because it's an important one, okay?
50%.
I'm not going to show you how to do the sine one because that's just going to be in the exercise. This is the idea of what you do.
Oh, indeed, 50%.
Mm-hmm.
I was meant to ask you this because I was updating the notes thing.
Mm-hmm.
You see, where do we get the 3 and 7 from, and how do we do that?
The 3 and 7 came from here.
Where's
Where-
this coming from as well?
So we know that the limits of this, just for the video's sake, we're doing something completely different here. So this is ln2 and ln6 are the limits.
Mm-hmm.
So when x is ln, oh, I'm sorry. When x is ln2, you have to find out what u is equal to. And we did that by using what our substitution was. Now, our substitution was 1 plus e to the x. So when x is ln2, you get 1 plus e to the ln2.
Oh.
Because when
I'm
you
so
do
stupid,
you do
yeah.
substitution, you have to change the limits
with
as
it.
well. Because
Okay.
everything needs to match the du or the dx or the thing that you're doing it with. Okay. So if you have finished writing it, we can only integrate these functions in some particular situations here. And it's when there is a 1 that is at the top. And when we have nothing in front of the x squared, when it's just 1 and x squared there. That's what makes this integration unique, is where it has to be a 1 on the top. Well, it doesn't have to be a 1 on the top, actually, because you can obviously scale it. But the important thing is that it has to be an x squared. It can't be like a 7x squared. You would have to factorize out.
What do you mean? What?
You'll see with some examples, okay? So if they look of this form here, we now know a sort of fractiony looking kind of thing we can integrate using Arctan. So let's have a look at a couple of them. This first one that I've got here, the integral of 4 over 5 plus x squared dx. I would look at this and I would say, it's not the reverse chain rule. It's not going to be polynomial division. It's not going to be partial fractions. I'm going to turn to my formula book. In fact, you'll probably get used to the fact that this is going to be like an arctan or an arcsine. We know it's going to be an arctan because there's no square root that we've got there. So you carefully look through which of these forms it looks familiar to, and it looks familiar to this one. Now, if you want to, which I probably would do, is you can think about, if I pull the 4 out, I then get 1 over 5 plus x squared dx. Right? I think of pulling the 4 out. You don't have to pull the 4 out. You could just know it's going to be 4 times bigger of the thing that you've got. Now, I personally write down what a squared is equal to, because a squared is the thing which is 5, which tells me that a is equal to the square root of 5. And I know that sounds really, really stupid because you can just see it. But when you're then substituting things in later on, you might end up substituting 5 in place of a instead of the square root of 5. So it's just trying to make your life easier for this. So when we actually do the integration, we get 1 over a. So it's going to be 1 over root 5. Oh, it's going to be 4 actually, because we've got the 4 outside the front. So we get 4 over root 5 arctan x over root 5 plus c. Because this is...
Pi minus 1 is different to Arctan. There's a whole video on YouTube, trust me. It's very interesting.
So this is just the language that we'll use in calculus, okay? We'll use this as the more formal way of writing it, okay?
Only because sometimes I forget that.
Yeah. Okay, and that's it. That's that integration done. It's just about making it, manipulating it, and so that it looks like the correct form. This one doesn't look like the correct form. You might be tempted to say that a is equal to 5. But a is actually not equal to 5 here, because the x squared coefficient is 9. And in our standard formula, the x squared coefficient has to be 1. So what we should do here with our 1 over 25 plus 9x squared is I should factorize out a 9 on the bottom. So I have 9, 25 over 9 plus x squared dx. And if you want to, you can pull out the 9th all the way to the front. So you get 1 over 25 over 9 plus x squared dx. We can then see that a squared is 25 over 9. So a is 5 over 3. And I think you'll see now why I like to write out what a is separately. Because when you do the integration, you've got the 9th, which is still there. and the standard pattern says it goes to 1 over a, which is going to be 3 over 5, arctan x over a. What's x over a going to be?
3x over 5.
Yep. Because over a just means inverse a, or reciprocal of a. So just be using 3 over 5. So when we simplify this down, we can cancel those. So we get 1 over 15. Thank you, Luke. 1 over 15 arctan 3x over 5 plus c.
So the formula that we proved in this question
Yes.
is a renowned formula.
Yes.
Okay.
So when it's now that we have found this formula, we always use the standard result unless it says show using a substitution or prove that this is equal to this thing. Okay? So it will be clear in the language of the question if it's asking for you to do it in this formal kind of way like this. If it's asking you to do it in this formal kind of way, it will be quite obvious, I hope. And there's going to be some questions like that in your exercise as well. It will also come up when we do the stuff on hyperbolic functions too. Yeah, Hamza?
So the aim of the question is to find out what A is, and then know which one of these is B.
Correct.
Okay.
Get it in the right form, and then and it's a manipulation kind of skill. The harder thing I think that you'll probably come across is doing the substitution, but you can do all 4 of these now. We'll do these bottom 2 when we do hyperbolic functions, but you could do all 4 of them right now, and if that comes up in the exam, it's done. Like came up in the exam, in the 2019 exam for further maths, I think. So, you know, it's like 3 marks. I don't know, I didn't check it, because it was long gone at that point, they were all done. Okay, so we've got a couple of questions here. These are more challenging, because there's some things that look a little bit different about these ones that we've got here. So obviously we've got some limits, let's not worry too much about the limits, but for this first question that I've got, I'm trying to integrate between minus root 3 over 4 and root 3 over 4, 1 over the square root of 3 minus 4x squared dx. Now, obviously, this is coming up in this chapter, so we know it's not reverse chain rule. We know it's not this, that, or the other. We know it's to do with these 4 things that I've got down in the corner of the board. But you should look at this, and you should recognize it is none of those other things, and it should then be telling you, cool, because it's going to be one of these things. In further maths, you could still be asked anything from normal maths. It doesn't mean it's going to definitely be something from the formula book. So it's your skill to decide when you're going to have to turn to these pages in the formula book. Now, which one is this going to be integrating to? No, sine. I mean, sine and cos are the same, but the formula book is always going to be with arc sine, okay? So we still need to manipulate it so that we have got... so that we have a squared and x squared. At the moment, we've got 4 in front of the x squared. So what do I need to take out on the bottom?
A squared is 3 and...
A squared is not 3.
You need to get out a factor of 4.
Almost, and you take out a factor of root 4, because the whole thing is being rooted.
Yeah, so the factor of 2.
Yeah, so let's take that a little bit more slowly. So I'm going to be doing from minus root 3 over 4 to root 3 over 4, 1 over. If I take out root 4, I would get root 3 over 4 minus x squared. From the properties of surds, these 2 things you can multiply out because they've both got surds. So you can multiply the surds together.
So you can't just take...
Can't you just do it as 3 is a squared and then 2x is...
You possibly can do, but I'm going to advise you against that because the scaling is going to be, it just gets a bit confusing with the scaling. So I always want you to just make x squared have a coefficient of 1. There are ways of thinking around it, but if we just do it this way, it will always work, okay? So you've got to take out a factor of root 4 here, which is a bit strange because it's got a root there. So the 1 over root 4 I'm actually going to take out as a 1 over 2. And it's going to be from, still writing these really annoying limits that we've got here, we've got 1 over 3 over 4 minus x squared. So what's my value of a squared?
Wait, 1 over 2?
Yeah, because 1 over root 4 is 1 over 2. What's a squared?
You can't take the negative value ever of a root in this topic.
Nope, you won't. No. What's my value of a squared?
3 over 4.
What's my value of a?
Root 3 over 2.
Root 3 over 2.
Ooh, that's nice, isn't it? This is why you've been asked to memorize certain things. Okay, so we have now got a half. And now I'm going to open up my limit brackets that I've got here. What does this integrate to?
Wait, what?
What does this integrate to?
Oh,
Just
Ah.
minus
cos.
3 over 4.
No, it's 1 over.
Just use the bloody formula page, guys.
Yeah, wait.
Yeah, but 1 over a is 2 over root 3,
Okay.
and then
Where am I doing 1 over? Why are you doing 1 over a?
Arc sine.
arc
2
sine.
Thank
That's the
you.
one.
Arc sine of 2x over root 3. Don't bother doing any rationalising, okay? You'll see why. So we've got minus root 3 over 4 and root 3 over 4. Now you're going to substitute in root 3 over 4 and minus root 3 over 4. So you've got 2 over root 3 times root 3 over 4.
2 half.
A half. So you've got a half, and then you've got arc sine a half minus, what's 2 over root 3 multiplied by minus root 3 over 4? So you've got arc sine a half minus arc sine of minus a half. What is the inverse sine of a half?
half 2.
30. 30 degrees.
Come on, it's radians, guys.
Pi over 6.
Okay, what's the inverse sine of minus a half?
Minus pi over 6.
Good. Minus pi over 6. What's a half of pi over 6 plus pi over 6?
Pi over 6.
Okay? So it's pi over 6. And then here comes the fun question. So let's move this across. And then we're done for today's lesson, but you'll just do some practice for me. Did I copy this separately? Right. So what's different?
Then the x plus 4.
Okay, what do you think could be our strategy to deal with this?
Take out 4 over 4. No, it can't be that. No. Oh, split out.
Yep, split the
Fraction.
numerator. That's one of our techniques for normal math, isn't it?
X over 1.
So if I'm going to integrate x plus 4 over the square root of 1 minus 4x squared dx, that's the same as integrating x over the square root of 1 minus 4x squared dx plus integrating 4 over the square root of 1 minus 4x squared dx. If you want to work these two things out separately and put them back together, or we can just do them all at once. Should we do them all at once?
Yeah, sure.
Okay, so how do we integrate this?
Take out back to root 4 again.
Nope.
No?
It's the 2x one.
What's the 2x one? That doesn't mean anything. What do you mean the 2x
Like,
one?
as in, we did it on the board, it's like 1 minus.
What do you say, Nahid?
4.
Yeah. No. You can't take out x. It's not a constant. Get out of this classroom and go
Reverse
into...
chain
Thank you.
rule, Because it's the derivative
Oh
of
my
the 4x.
gosh.
It's a reverse chain rule. This I did tell you just now. Further maths won't just be further math stuff. It will have normal math stuff in it as well. So this is the reverse chain rule. You might like to rewrite this as x 1 minus 4x squared to the minus a half. Okay? We're going to do this quicker than we would do in normal maths. So what's the function I'm expecting it to, what's the function I'm going to consider? So it's going to be 1 minus 4x squared to the half. Well, let's differentiate that in our head and see what we get and then scale it.
Half.
Half
And then-
minus 8x.
You get minus 8x. Half times 1 minus 8x.
Okay, so what do I want to scale it by?
Minus-
Quarter.
Minus 4.
Are you sure?
Yeah, because the derivative of blah is minus 8x.
Good. I was just checking. Because the derivative of this, when you do the whole thing, you get a minus 4x, so you have to minus quarter it. Now here, I am going to have to factor out the 4 in front of the x squared, but I'm going to have to factor out a root 4. So I'm going to get plus, let's take out the, I'll take out the 4, and I'm going to do another step. Should I take out the root 4 as well? And then I've got 1 over, when I take out the 4, I get 1 over 4 minus x squared dx. I did a couple of factorising out there. I took out the 4, I took out the root 4, which left me with these things that I've got. Now for this little bit that I've got over here, a squared is,
Quarter.
a is
Half.
a half.
Half.
So when I come back to this, I get minus 1 over 4, 1 minus 4x squared to the half, plus, what's 4 over root 4? Plus 2, and what's the integral of this?
It's sine, so it's arcsine x 2x.
I probably would write this as minus a quarter root 1 minus 4x squared plus 2 arc sine 2x plus c. Exercise 3D, even questions.